Hi guys, and welcome to Caribbean Suits. In this series we'll be looking at the chemistry syllabus. Today we're starting with 1.2 and 1.3 in the chemistry outline, and this topic is the states of matter. First we'll be looking at the different states of matter, then we'll be looking at how each state of matter is converted to the other, or the process by which each is converted to the other, and finally we'll be looking at the heating or cooling curve. Alright, so first we have solid, liquid, and gas. What we're going to do is we're going to identify the different states of matter. Solid. Now the shape of a solid is fixed. Any solid that you look at, you're going to see that it has a fixed shape. It doesn't change randomly. So we say that the shape of a solid is fixed. Now, density means how much particles or how close the particles in the substance are to each other. So the density of a solid is really high because, as you can see in this diagram, the density of a solid is really high. The particles are packed close together. There's not much space between the particles of a solid, so we say that the density of the solid is really high. The volume of a solid is fixed. How much particles the solid had is fixed. It doesn't randomly change unless you add more particles to that solid, or if you cut a piece of the solid off and change the volume. But usually we say that the volume of a solid is fixed. Compressibility. Compressibility simply means how able, or if it is possible for you to compact or push the solid together to form a different shape or to make it smaller. So because of how tightly packed the particles in a solid are, we say that it's very difficult to compress a solid, or no compressibility. Okay. Forces of attraction. Now the forces of attraction that we're talking about, you'll learn more about it further in the syllabus, but today think of the forces of attraction like magnets, the magnets being attracted to each other. So the forces of attraction in solids are really strong, which is what contributes to the tightly packed particles. So they're really strong like magnets attracted to each other. So the particles are really tightly packed, so we say that the forces of attraction are strong in solids. Okay, energy and movement. Now because of how tightly packed the particles in the solid are, we say that there's little energy in these particles. The energy that we're specifically talking about is kinetic energy. Kinetic energy is the kind of energy that you have when you're moving up and down. So because the particles have little or no space to move, we say that the particles in solids have little energy. Movement, again, because of how small the spaces between the particles are, we say there's little or no movement. What actually happens with the particles in solids, however, is that they vibrate. They don't get to move around like liquids, or the particles in liquids or gases, but they vibrate. So I can draw some little quotations to show that these particles are vibrating. They're not moving to go anywhere because they have little or no space. Okay. Liquid. The shape of a liquid is the shape of the container that it's in, or the shape of the part of the container that it's in. Imagine pouring some water or some juice into a container that has a circular. Imagine pouring some water to a container that has a circular bottom. We say that the shape of this liquid takes the shape of the part of the container that it fills, or the bottom of the container. If it was a triangle shaped container, even though it's the same liquid, it takes the shape of the triangle shaped container, and so on and so forth. So the density of liquids is much lower than the density of solids, but much higher than the density of gas. Why is this? The spaces between the particles in the liquid are much wider than the spaces between the particles in the solid. So they're not as they're not as compact as the solids, but they have a little bit of room to move about. So we say that their density is less. There's less particles for the volume. Okay, compressibility. Because the liquid has spaces between the particles, unlike the solid, we say that liquid has little compressibility. So we have a liquid. We have a liquid and there's spaces between the particles, probably not that wide. Well, let's say there's spaces between the particles. Alright. If you have something to push down on this liquid, it would be able to move a little bit. So that's what we mean when we say compressibility. Because there's some spaces between the liquid particles, you can use something and push down the liquid a little so that the particles fill up the spaces that were empty. Alright, forces of attraction. Now the forces of attraction in a liquid are weaker than the forces of attraction in a solid, but much stronger than the forces of attraction in a gas. This is why that the liquid has spaces in between. So because it has weaker forces of attraction than a solid, the particles aren't as strongly bonding to each other, or they're not as attracted to each other as the particles in the solid, so they have spaces in between them. Okay. Energy and movement. So in a liquid, since we have some spaces in between, we say that the particles have more kinetic energy than the particles in a solid, but less kinetic energy than the particles in a gas. So there's a little bit of space between them, not as much space as a gas, but just enough for them to move a little bit. So in the liquid, hopefully you can see this in the liquid, they can move these directions in between the little tiny spaces, and that gives them a little more kinetic energy than the particles in a solid. So movement, energy, kind of similar. Movement, it moves in all directions. They glide slowly past each other. The particles in liquid move slowly past each other because they have a little bit more kinetic energy than the vibrating particles of the solid. Gas. Now the shape of gas is the shape of the container that it's in. The particles of gas just decides to spread out and fill the entire container that it's in. So if you bottle up some ammonia, if you bottle up some chlorine gas, it's just going to take the shape of the entire container that it's in. Density. Gas has a ridiculously low density, which is why the particles are so far apart and just like to do what they want. So we say gas has lower density than liquid, and by far a lower density than solid. Volume. So just like the shape, the gas decides to spread out and just take the volume of the entire container that it's in. Compressibility. If you're understanding how compressibility works, I'm going to draw this back. I'm going to draw it here. Let's say we have some gas. Let's say we have some gas particles. They're really far apart. I have some gas here. Right. Nice. So imagine you have the same pump like we have in the liquid. But when you push this pump down now, it would be able to move further than it did in the liquid. Why? Because the gas particles are further apart, so they have more space for you to be able to compress all the particles together. So we say the compressibility of gas is high, which would mean higher than liquid, and by far higher than the compressibility of solid. Okay, forces of attraction. Gases, because of how far apart they are, we say they have weak forces of attraction. They're not as close as a solid, so their force of attraction is really weak, which allows them to be moving so freely. If their force of attraction was really strong, they would be tightly bound to each other, just like particles in the solid, and they would be rigid. However, gas particles have weak forces of attraction. So, their forces of attraction between each other are very weak. Okay, energy and movement. So gas particles have a lot of spaces between them. So there's a lot of kinetic energy going on. There's a lot of space for them to move. There's a lot of space. See this space? There's a lot of space for them to move. So they will move. They move in all directions, and because they have so much space, they have a lot of kinetic energy. So they gain a lot of kinetic energy from moving. And we say that they are high energy particles. So the gas, the energy in the particles of gas has a lot of energy, and they're moving in all directions because they have so much space to be able to move about in. So gas has much more energy than the particles in liquid, much more energy than the particles in solid, which only vibrate. Okay. So over here we're going to talk about the different states of matter and the processes by which each state of matter is converted to the other. Solid, liquid, and gas. In this example, what we're going to do, we're going to look at ice, water, and steam. So imagine you have a cube of ice. This is a cube of ice. That's our solid. If you want to make the cube of ice into liquid, what do? You add heat. So by adding heat, and by adding heat, you melt the solid to form a liquid. So the process by which a solid becomes a liquid is called melting. Okay. Next, we have liquid to gas. Imagine you have some water. You have a glass of water or a pot of water. And you want to get some steam from this water, right? What do? You add heat. So we have a pot of water, we add heat, and we get some steam. Okay. So the process by which liquid becomes gas is boiling or evaporating. So we say boil the water. That's boiling or evaporating. Later on I'll explain the difference between boiling and evaporation, but for now, the process by which liquid becomes a gas is by boiling or evaporation. Alright, so we went this way, solid to gas. Now we're going to go this way, gas to solid. Alright, so in the event that you have some steam now, you already have your steam. And you want to get some liquid. What do? You remove heat or you cool the steam. And this process is going to be condensation. The process by which a gas becomes a liquid is called condensation, and this happens because you're removing heat or you're cooling the gas. Okay. If you have a liquid and you want to make it a solid, what do? You freeze it or you cool it. So freezing is really cooling the liquid. So we say that liquid to solid is freezing. So you have some water and you want it to be ice. You just pop it in the freezer. It loses heat, you're cooling it. Before we move on, there's something very important that we need to note here. Solid, it has little bit of energy. Remember we spoke about solid over here? How the particles don't have as much energy as a liquid. So if you want to make it a liquid, you add some heat. Now when you add heat to the solid, you're giving the particles some kinetic energy. so they become further apart and they start forming liquid, which is why we get a liquid when you heat a solid. Now, if you heat a liquid, you're adding some more energy, adding kinetic energy to the liquid, and with this increase in kinetic energy, you might just be able to get gas, which is why we have gas. So as you move from solid to liquid to gas, you're adding heat, which also means you're adding energy. So you get to increase the energy of the solid to get liquid, increase the energy of the liquid to get gas. And it works for the other way around too. I'll just go through it. So if you have a gas and you want to get a liquid, you remove some heat from it, you cool it down, which removes energy, and you get a liquid, which is a lower energy state of matter. So if you have a liquid and you want to get a solid, you remove some heat from it, you cool it down or you remove energy from it, and you get a lower energy state of matter, which is a solid. Oh, before we move on to the heating or cooling curve, it's important that I identify the difference between boiling and evaporation. Essentially, evaporation can occur at any temperature. So at any temperature, it could possibly be 0 degrees Celsius, it could be 50 degrees Celsius. You can get a liquid, you can convert a liquid into a gas by evaporation, any temperature. However, boiling occurs at a particular temperature. For water, we know the boiling point of water is 100 degrees Celsius. For different molecules or different substances, the boiling point is different. But for a particular substance, you can only have boiling at a particular temperature. So just recap, evaporation takes place at any temperature, boiling takes place at a particular temperature for that particular substance. Okay. The heating or cooling curve. What exactly is this funny looking curve that we have on the board here? So what happens in this heating or cooling curve is you usually start off with a solid, or you can start off with gas depending on which one you're doing. Right here I'm looking at the heating curve specifically. So this curve shows that we're starting with a solid, which is ice. And as it melts, we have a thermometer, we check the temperature at different time intervals. So at 10 seconds, we probably check the temperature again, 20 seconds, we check the temperature again. But the important thing is that we're checking the temperature and we're monitoring the state of the solid. So, let's go. At this point, it's ice. Right here, we reach ice at 0 degrees Celsius. So this is ice, this point is ice at 0 degrees Celsius. The y-axis shows the temperature, the x-axis should really represent time. As time progresses, the temperature increases. Alright, so we're increasing the temperature and the ice is going to increase in temperature as well. So right here we have ice at 0 degrees Celsius, because we're adding heat. So at this point, we realize that there's a plateau. We see the plateau in the graph of the heating curve. What does this plateau represent? This plateau is the phase in which there is no temperature change. Remember, it's still at 0, still a straight line to 0, so it's still at 0. However, all the energy that it's getting from the temperature, from the heat, is going to be used to convert ice into water or liquid. Alright, so at this point, at the end of that process, we have liquid. Since we're specifically talking about H2O, say water. Water. Okay. So, at this point we have liquid or water. What happens here is that the temperature continues to increase. So this liquid water gains some energy and increases in temperature. So we're moving away from the ice cold water closer to the 100-degree water. Now, what did we say happens at 100 degrees Celsius for water? This is temperature in Celsius. So what do we say? Oh, this is a very lean line. What do we say happens at 100 degrees Celsius for water? Boiling or evaporation, right? Right. So at this point, as the graph rises, the liquid or water is gaining some energy, and it becomes water at 100. So that's boiling right there. So right here we have melting, I forgot to mention that. And right here we're going to have boiling. So the water has gained some energy and now it's ready to become a gas. So what happens at this other plateau, there is no change in temperature, it's still 100 degrees Celsius, right? This other plateau we have water forming steam or gas. So water forming steam or gas. So at this point, we have steam. And that steam would be at the same 100 degrees Celsius that the water is at, because remember there was no change in temperature. It was at plateau, no change in temperature. So as you add more heat, the steam gains more energy, increases in temperature, but that's the synopsis of the heating curve. So just to recap, the heating curve, we start with ice. Ice that's lower than 0 degrees Celsius, we add some energy or some heat, and it becomes ice at 0 degrees Celsius. This ice at 0 degrees Celsius experiences melting as it uses the energy to move from ice to water, which is the solid to the liquid state. And at this point, there's no change in temperature, so we say this is the plateau. Okay. When the ice becomes water, it's water at 0 degrees Celsius at this point. So the liquid or the water gains some energy, increases in temperature, and becomes water at 100 degrees Celsius. Now at this point, we have water at 100 degrees Celsius and it's using the energy. The temperature is not changing, plateau, temperature is not changing. So it's using the energy to convert itself from a liquid state to a higher energy state, which is steam or gas. So at this point, we have steam or gas. And that steam just continues to absorb some more energy and increase in temperature. Okay, so that wraps up states of matter for this video. Just to recap really briefly. We have solid, liquid, and gas. Those are the 3 states of matter. Solid has a fixed shape, has high density, fixed volume, hard to compress, strong forces of attraction, vibration for energy, little movement. Liquid has the shape of the container, lower density than solid, but higher density than gas. The volume, it doesn't change. Compressibility, it's little or partially compressible. Forces of attraction are stronger than that of gas, but weaker than that of solid. Energy or movement, more energy than solid, more movement than solid because of the space in between the particles. Then we have gas, which takes the shape of the entire container that it's in. The density is not very great, it's lower than solid liquid. And the volume takes the volume of the entire container. It's easily compressible because of the spaces between it. Forces of attraction are very weak. Energy and movement is very great. And last, to form a liquid from a solid, we have melting. Liquid to gas is boiling or evaporation. Gas to liquid is condensation. Liquid to solid is freezing. So it's important to recap because I forgot to tell you that there's a process that converts solid immediately to gas, and that is sublimation. You can convert a solid straight to gas without reaching the liquid state, and you can also convert a gas straight to solid, and this is called deposition or deposition. And the heating or cooling curve, remember we start with ice below zero, or ice at a temperature that's lower than zero. It gains some energy, becomes ice at 0 degrees. We have melting right here as ice becomes water. Then we have water at 0 degrees. Then we have water that gains some energy and becomes water at 100 degrees Celsius. Then we have water becoming steam without any temperature change. So that would be boiling or evaporation. And then steam gains some energy. Alright, so that wraps up this video, guys.